Greetings, my name is Jim Long. I'm a principal cloud architect with AWS's Global Financial Service Practice. Today we have David Jackson, a Director of Cloud Architecture from Fidelity Investments, here to talk to us about how Fidelity has built a serverless platform to operationalize cloud observability at scale. David works in Fidelity's Cloud Center of Excellence. The mission of the Cloud Center of Excellence is to enable Fidelity business units to adopt the cloud at scale while managing risk. David, thanks for taking the time to show us how your team has addressed observability while scaling to hundreds of AWS accounts.
Thanks, Jim. And hi, everyone. As Jim mentioned, I work with Fidelity's Cloud Computing Group. Now, Fidelity follows a shared responsibility model where that Cloud Computing Group manages the overall health and observability of our cloud infrastructure, leaving each individual team to look after their own application's health. Today, I'm really looking forward to showing you how we have used the tools and data available from AWS to operationalize the observability of our cloud infrastructure at scale. And it's scale that's at the heart of the challenge for an enterprise like Fidelity when looking to adopt the public cloud. Fidelity has, over the last few years, been rapidly expanding its use of public cloud and AWS, running an ever-increasing number of production workloads there. Some organization or business units within Fidelity were early adopters of the cloud, pushing the boundaries and paving the way for others to follow. Today, all our business units are at different levels of maturity in terms of their cloud journey. Because of that, it's imperative for Fidelity to be able to consistently, holistically, and proactively manage the health of our public cloud infrastructure. In order to do that, data is the key. Data has provided the answers to problems we have had on our own cloud journey as an enterprise. And yes, we have had bumps in the road. We have had, for example, avoidable EC2 outages that have affected our production systems. We saw from consolidated support case data from across the enterprise that some business units have been opening critical support cases from their production environments when an EC2 unexpectedly to them had been stopped by AWS. In fact, they had received notifications from their personal health dashboard weeks beforehand, letting them know that EC2 was running on old hardware and needed to be restarted. If not, it would be stopped by AWS. Now, we failed to either see that message or get it to the right person. We knew from incidents like this that we needed a clear picture on what the current events are that are affecting our accounts, and also a clear picture on the scheduled maintenance that's due on our accounts in the future. We also knew that leaving this problem for individual teams or business units within Fidelity to solve was an approach that wouldn't give us the consistency we need, but also just wouldn't scale. So we created a solution that would. Now, I've mentioned scale a few times. So what does scale mean at Fidelity when we're talking about the public cloud? Well, today we're running many hundreds of production workloads in AWS today. Those workloads are spread over approximately 1,000 AWS accounts if we include non-production and production environments. Those accounts are managed by a variety of internal business units, some large, some small, some experienced cloud practitioners, and some new adopters. Overall, Fidelity is a huge technology organization with over 12,000 geographically dispersed developers spread right around the world. All these facts set a significant challenge for us to provide a safe and consistent operating environment for our production workloads to run in, whilst avoiding unnecessary outages, such as that EC2 outage I just described. So with that context, in this session, I'm going to present to you a two-part solution that we created that allows a small team of engineers to manage the operational health of such a large cloud footprint. That two-part solution consists of a push and a pull, representing how we communicate the health and support case data to our internal business partners. That's either through push notifications or allowing them to pull data through analytics dashboards. In order for those two solutions to work, we need accurate and up-to-date health and support case information. We'll talk about where we got that data from. Then we'll dive into the solution itself, which is a fully cloud-native serverless solution. We'll talk about the architecture and the implementation. Finally, we'll see what all that has produced through a demo of our cloud operations dashboard solution, which gives full cloud observability based on near real-time data. So let's get going, and let's start with a push and a pull. As I mentioned, push refers to push notifications. That's from our Cloud Event Processor application. That takes events from Personal Health Dashboard, or PHD, and routes them to the relevant account owners and account users who really need to know about that event. On the pull side, we have our Cloud Operations Dashboard. That presents both current and past health and support case information, effectively creating a single pane of glass to allow our business unit partners to filter and sort data in order to answer questions that they have about their cloud environments, such as, what are the current issues that are affecting my account right now? What scheduled maintenance is due in the future that could affect my account's resources? What support cases, or how many support cases, have we raised last month versus the previous months? And what were the response times on those and resolution times? So that's our push and pull approach. But for that, we need the data, and it is out there somewhere. And in fact, AWS provide a range of APIs and events that allow us to get the full set of data we need to present that health information. Starting with the Personal Health Dashboard PHD. We hook into the events issued by PHD to provide push notifications to those account owners and users that need to know. The Support API allows us to pull both current and past support case information for each account in the enterprise. And we can analyze this data at either a macro or a micro level. So at a micro level, we can take a case of particular interest to us and look at all data on that case, including all communications back and forth between Fidelity and AWS. At a macro level, we can look at trends in cases, whether it's breaking cases down by category, severity, environment type, service associated with the case, and so on. AWS Organizations allows us to group our accounts according to our internal business unit structure within our own enterprise. That allows us to take health case data or health event data and support case information and group them according to the business units so that they can see the data that matters to them most. Finally, we can add our own custom data sources to this mix to add additional context or additional data points that AWS just can't provide. For example, for push notifications, we can tap into our own data sources that can identify who the account owners and users are that are relevant to the notification so that we can deliver them to the right people. We can also tap into our own internal data source on our cloud inventory database. So when we get an event, we can assess the impact of that event, and we can assess potential risk to other accounts who have not received that event yet. Let's dive into two of these now, the Health API and the Support API, for a little bit more detail. Starting with the Health API. With this, we are able to make a single API call at an organizational level to retrieve all health events that have occurred in a given time period. That's a powerful tool that we use to fuel our cloud operations dashboard, which is something I'll demo later on. Here we're looking at the event details endpoint, and I've highlighted a few fields of interest that have given us particular insights that we've needed to solve some problems we've had. Starting, for example, with the event type category field. This lists which category a particular health event falls into out of three main categories that AWS provide. That's account issue, something that's affecting a resource in your account right now. An account notification, which is like an operational notification related to a service that your account is using. And finally, scheduled changes. So these are upcoming scheduled maintenance events that could affect your resource at some point in the future. With this data, we can list all the scheduled change events combining with the status code field that we also see here to make sure we see a list of upcoming scheduled maintenance events. This allowed us then to create a clear list, for example, of EC2s across the enterprise or within a business unit that are running on old hardware and that need to be remediated before AWS are forced to stop that instance. This has allowed us to avoid those incidents I've talked about before by having a clear list of when these are coming up. On the support API side, there's the describe cases endpoint. And this basically gives us all the details about cases and communications of support cases for a particular account. So looking at some of the fields we get back here, the service code field allows us to identify the service that the support case is related to. With this, we can identify patterns or trends over time, like using that to identify education needs. If we have a lot of general guidance requests on a particular service, maybe that's something we can work with AWS to get pinpoint education in our enterprise for that. Similar, if we see common issues, we can work with our AWS partners to try and find resolutions to those common problems. We can also use the service code field to identify service limit requests. These are increase requests for soft limit increases on certain AWS services. For example, the limit on how many cloud formation stacks you can have in a particular account. With that data, we can identify which service limit increases we're commonly requesting, and maybe we can think about automating some of those at account creation time. The severity code field shown here gives us the severity of the case, from low all the way up to the maximum, which is critical, which demands a very fast response time from AWS. We can provide filters on our cloud operations dashboard, which shows clearly what the most important cases are that need attention right now, being of the highest severity, say critical or urgent. Also shown here is the status field, and there are many possible states for a support case that's in flight at the moment. Could be opened, could be resolved. One that's of particular use to us is pending customer action. We often see many cases in pending customer action state, and that means that that case is sitting with Fidelity, not AWS, to take the next step. That could be to provide more information or confirm that the issue has now been resolved. It's important for us to remember that it's as much up to us as it is AWS to resolve support cases as quickly as possible. Separate to the direct API data that we get back from support and from the support and health APIs, we also derive some additional data, and some of these are worth calling out. So from a support case perspective, we can calculate MTTA and MTTR for our support cases based on the dates of communications that are on the case, relative to when the case was opened. This allows us to identify delays on the case, and that could be either from ourselves or from our AWS partners. Either way, any delay in a case is a problem, and we need to know about it. In fact, in our experience, the majority of any case delays are usually due to a delay on our side. And so we mark those cases as case delayed by customer. This has been a useful insight, which has helped us to drive down the number of cases that are in flight and reduce overall resolution times, which benefits everyone. Also, the time to acknowledge that we calculate on each case has allowed us to compare what the response time was in the case versus what we expect from AWS in terms of perhaps the SLA based on the severity of the case. Now, this has helped our operational conversations a lot because we're able to base those on real data, not just individual cases and not anecdotal evidence about particular cases. So we've talked about the problems of adopting the cloud at scale from an observability perspective, and we talked about the data that's available. Let's dive in to the actual solution itself that we have created. Now, I'll walk through the architecture in a moment, but at a high level, this is a list of the serverless services we've used from AWS to put this solution together. From our dashboard perspective, we basically have a batch job that collects health and support information from the APIs, saves them to a data store, being Dynamo, and then exposes that data to our partners to QuickSight dashboards. So walking from left to right, we use CloudWatch events to trigger the data collection process. We run that on an hourly schedule. We have a set of Lambda functions that call the APIs to collect the data. These functions are orchestrated by step function workflows. DynamoDB is our persistence layer. We use that for the flexibility it gives us as we are dealing with quite a dynamic set of data that could change rapidly over time. There is currently no direct link between Dynamo and QuickSight to populate the dashboards, so to bridge that gap, we export the DynamoDB table to S3 buckets in the form of JSON files, and then QuickSight consumes them. So that's the high level in terms of the services. Here's the architecture of the overall solution. On the left side of this diagram is the health data collection process. On the right side is the support case data. Both sets of collection processes save the data in the middle in DynamoDB tables, and then in the center of the diagram export to JSON files in S3. They are picked up by QuickSight and the dashboard is exposed. Now, there is a lot going on here. So what I'm going to do is I'm going to break this down into two halves, starting with the left-hand side, which is the health data collection process. CloudWatch event kicks off a step functions workflow on an hourly basis. That workflow coordinates the steps needed to retrieve the health information, starting with getting the list of events and then proceeding to get various details of those events, saving all that data to DynamoDB tables. We export the contents of the table to JSON files in S3 bucket, and QuickSight then consumes it. Now, the workflow here is key to giving us a flexible design, as we expect and plan for further changes to how we collect this data in the future. It also makes it a very testable solution as well. But remember, there are two parts to this solution. So let's take a look at the right-hand side of the diagram, the support case data collection. And this follows a very similar pattern. CloudWatch event kicks off a step function workflow on an hourly basis. The first step in the support case workflow is to get the list of accounts in our organization. This is because the support API is slightly different than the health API. So we need to call support API on a per account basis. We can't make a single API call to get all the support cases for the org just yet. So once we get the list of accounts, we iterate over each account in the organization to retrieve case and communication details. Again, saving them to Dynamo, exporting to S3, and QuickSight is then able to consume that data and combine with the health information. So overall, this is actually a pretty easy to maintain, simple batch data collection process. Now, the key component of that architecture is the workflows, right? So let's take a closer look at those. Starting with the support case workflow, which is the simpler of the two. We start by getting a list of the accounts, as I mentioned, and then we follow a fan-out pattern. So in parallel, we're able to collect support case data for multiple accounts at a time. And step functions really allows us to do that very easily based on a simple parameter. So we can control just how much we fan out so that we don't overload the API. We have a dead letter queue state, so any failures will be stored for reprocessing later to make sure we don't miss any data. And finally, we save the data in Dynamo and export to S3. Now, on the health API side, the workflow is a little bit more complex. This is despite the fact that there is a single API endpoint for us to hit to get all the events for the entire organization. But once we do get that list of events, we follow a similar fan-out pattern to what we saw on the support case side, because we have various endpoints to hit to get the full details for each event. That includes getting the affected accounts, getting the affected entities for the event for each account, and getting the full details for the event. Again, we've got a dead letter queue in case any of those steps fail, so we can reprocess later. We save the data and export to S3 for the dashboard. So that was the dashboard solution. But remember, there's two parts to this solution. So let's switch gears a little bit and take a look at our real-time notification solution, the Cloud Event Processor. As a reminder, this is intended to deliver real-time notifications that matter to relevant account owners and users. Note, it's equally important that those users are able to manage their own subscriptions so that they don't get overloaded with too many notifications. This avoids them then ignoring all the notifications and missing the really crucial ones for them. Now, again, there's a lot going on in this diagram. So again, I'm going to break it down into two halves. So on the left-hand side, we have a batch process that basically collects who those account users are, which is a fairly dynamic list of people. On the right-hand side is the personal health dashboard event processing. So we get an event from PHD and we process that, eventually sending an email to relevant users. So looking quickly at the left-hand side, it actually follows a very similar pattern to what we saw on the dashboard. We've got a batch job triggered by a CloudWatch event, this time daily. And then we have a set of steps in a step function workflows that get a list of the organization's accounts, gets the list of groups that have access to those accounts and the members of those groups, and saves them all in a Dynamo table that we can use now, as I show you the right-hand side of the diagram, in our event processing itself. So the event processing really starts with the PHD event. We get that onto an SNS topic, which triggers a Lambda that takes the information that came from PHD, formats it, and passes that on to the step function workflow, which orchestrates the delivery of the email notifications itself. The first step there is to get who do we need to contact. That's the account owners and the account users, which we gathered on that left-hand side of the diagram earlier in our batch process. Once we have that full list, we need to be aware that some users do not want to receive all those notifications. So this goes into our subscription preferences. So we filter out a list of those users, eventually arriving at the list of users who really want to know about that event for those accounts. And we send the email using SES. Now that email contains a link which provides access to a Lambda-backed API that saves users' subscription preferences. So that link allows the user to opt out and say, I don't want to hear about notifications for that account anymore. They're not relevant to me. That's fine. We'll save that preference. And that immediately will act as an additional filter on the next event that we process from PHD. And that's our push model for delivering notifications for the events that matter to the people who really need to know. Again, the workflow model here gives us a lot of flexibility as we do look to improve how we target our notifications in the future. And overall, that's our solution for managing operational health at scale for Fidelity. But what have we learned from this solution? What new insights have we gathered from the data we've collected? First, a quick reminder of what scale means when we're talking about the cloud for an enterprise like Fidelity. We receive across all our accounts an average of about 3,000 or more health events per month. Of those, 100 or more are related to upcoming scheduled maintenance events that we need to be aware of and take action on that could affect resources in our accounts. For example, EC2 instances running on old hardware, as I talked about earlier. In terms of support cases, we raise over 150 support cases a month. On top of that, 80 or more support cases are also raised as service limit increase or soft limit increase requests for certain AWS services. All of these are spread across roughly 1,000 accounts if you include non-prod and prod environments. And thanks to the solution we've put together, this is managed by a small team of engineers, of only 4 engineers in fact. So that's the scale. But what are the benefits that we've got from this solution? Well, there are a number of new insights that we've gained, including what's happening right now on my accounts. We have a clear picture on that. We also have a key insight in terms of what is the scheduled maintenance. So for example, we have a clear list of the EC2s that are running on old hardware that are due to stop. We can now make data-driven decisions on whether or which service limits we want to automate increase of, maybe at account creation time. From a push notifications perspective, we are now able to deliver the notifications that matter to the people that really need to know. We are also able to reduce noise by giving them only the specific notifications they want to receive, which has resulted in increased awareness of those issues that really matter. We are able to have data-driven operational discussions with our AWS partners. This has improved those conversations enormously. As I mentioned earlier, it's all based on real data. Finally, and crucially, we have a very clear picture on what the critical issues are that are affecting or could affect our cloud infrastructure and our applications. So we're almost out of time. So I want to go through a very quick demo of our dashboard solution just to give an idea of some of those insights that I've described. So time is short. We're just going to dive straight into this. So this is the Open Issues tab, the first screen you see on our dashboard. And it's really telling you what's happening right now. Note all the data and all the business units that are showing here are artificially generated. And let's say I work for this fictional PRO business unit within Fidelity. And I'm really only interested in what's happening in production for my business unit. So I've got an executive summary front and center, which tells me how many cases are open, how many cases are pending customer action by us to advance, how many health events are open, and how many scheduled maintenance events are upcoming. So it gives me just that summary first. Then I can see a list of support cases that are either critical or urgent. So the most important cases. Notice many of these are in pending customer action state. That's something we need to take care of to move those cases on and get them resolved. There are also various breakdowns of the open cases that are affecting the account, including breakdowns by severity, status, environment, and so on. Also, we can see full details for each and every support case that has been opened, including who opened the case, and also what state it's in and what the criticality is. Also, we can look at similar breakdowns in terms of our health events. So how many open events are there? What services do they relate to? And how many upcoming scheduled maintenance events are there coming up that we need to be aware of and take action on? Finally, we can look at full details for every active health event that's open right now. So that's everything that's happening right now in our accounts. But let's take a look at Support Cases tab, which allows us to view not only what's happening right now, but also look at all the past support cases as well, to look at trends. And notice we've already filtered here by business unit and by environment. And we can see that there's various breakdowns available, whether it's by environment, by severity, by account, and by category. What are the common categories of support cases we've opened? And this is all filtered by this year. Now, there's various filters available to us. We can filter by status, by service, by environment, by severity of case, and various time-based filters as well. So what we're going to do is have a look at something we talked about earlier, which were support cases that have been opened related to EC2s. So we can filter our service by EC2, both Linux and Windows. And we can look at cases that have been opened against EC2, maybe of a critical nature as well. Let's just look at the most important cases. So that would be by critical or urgent cases. So we're going to apply that filter as well. And we can see we have 9 cases open this year from our production environments that were of critical importance related to EC2 instance issues. And we can see the full details of those cases, when they were created, who opened them, and so on. We can also look at the trends in those support cases. So over time, are we creating more or less of these EC2 support cases? Now let's unfilter. Let's just look at all support cases related to EC2 and across all environment types, not just production. Let's get the full picture. And again, from that trend over time, we can get some interesting insights. If we noticed a big spike in cases, as we did see in 2 months there in that chart, we obviously had a less stable environment at that time, and that's something we can take a look at. We can also look at service limit increases. So I mentioned earlier, we can filter for a service type of service limit increase and look at all those soft limit increases we've requested over time, both current and historical. And notice that VPC and CloudFormation limits very popular in our business unit. Maybe that's something we should consider automating for new accounts that we open in the future. And we can look at all the full details then of each of those service limit requests, who created them, what environment, the account, and so on. And the severity. Notice if we see critical cases for service limit increases in production environments, that means we've hit a limit that we really didn't expect, and that's something we need to review. So let's go on to the health events tab. And there are various health event breakdowns here, whether it's by type, account, severity, similar to what we saw in the support cases tab. There's also a bar chart you can see there, which gives us the kind of historical pattern over how many events we've received month over month. And we can see there was a particularly busy month there, and that's something we can drill into to understand why. We can also look at the upcoming changes. So we've talked about scheduled maintenance changes and being prepared for those. Let's filter to just see scheduled upcoming maintenance events for our business unit. And we can see this year we've had 126. Most of those have been related to EC2. And we can see there was one particular month that had quite a lot of scheduled maintenance incidents. So that, again, is something maybe we can drill down on in our operational conversations with our AWS partners. And so that's generally the kind of insights we can get from our health events tab. So the last feature that I'm going to show is related to the service alerts. So into the service alerts tab. Now this shows us events that have occurred that are not specific to a particular account in Fidelity. These are just general informational alerts that are sent out by AWS about an operational issue on a service that could represent a degradation on that service, but not necessarily. We can see which services are mostly affected this year, and maybe correlate to maybe some impact we saw on our applications or not. And we can also, as you can see, look at the full details of each individual service event that has occurred. So that's the demo. I hope that helps kind of visualize what I've been talking about. Now, there are 4 key takeaways that I want to leave you with today. First, data-driven decisions. So data really is the key to success at scale when you're operating in the cloud. Push and pull. Both real-time events and analytics together make a powerful cloud operations solution. AWS APIs and events provide us all the data we need to create that clear understanding of what the health of our infrastructure is. And finally, we have found that going with a cloud native and a serverless approach has allowed us to rapidly create a solution that works and that runs at a very low cost and that is easy to maintain. So with that, I really appreciate the time that you took to learn more about cloud operations at scale. Thank you for watching.